All right, well, thank you all for coming to the last sessions of the day. And so today I'm just going to be talking a little bit about my dissertation project. And so it goes well with what Andy presented. It's basically, I'm calling it collaborative revision for the purposes of this study, but you will probably recognize it as peer review. And so let me just talk a little bit about what I did. So in the fall 2012 semester, I was teaching an Emerging Scholars Program course through my university, and I decided to implement this teaching experiment using collaborative revision. And so here are the components. Basically, students write proofs at home based on statements that I give them, and then they bring them in, they present them to other students, and I chose to have the students work in small groups for this. And then the students will give them comments, they will give them critiques, and then the student will revise the proof, bring it back in, and present it again. And so this idea, has been done in English courses a lot, right? They call it workshopping a lot of the time. And so I thought about, what if we can do this with proofs? And so the context here is an Introduction to Proof course. So I was not the main instructor, and I'll talk about that in a second, but I was teaching it in this Emerging Scholars course. So let me just talk a little bit about Emerging Scholars at our university. I'm at the University of Illinois at Chicago. And we've had an Emerging Scholars program since 1989, so we've had it for a while. And if you know the history of the Emerging Scholars, it's sometimes called the Treisman model, based off of Uri Treisman, who developed it at Berkeley and who was also at UT Austin. And so we offer it for a bunch of different classes. We do it for pre-calculus, Calc 1 through 3, and then this Introduction to Proof course. And so here's just a little blurb from our website about what the goals of Emerging Scholars are at our program. It's supposed to be collaborative. They're supposed to work on challenging problems and that correspond to the main math course and emphasize the key ideas. So really, this project fit really well with the goals of the Emerging Scholars course, which I liked and which also the Emerging Scholars program director liked. And so usually these Emerging Scholars courses are taught by specially selected graduate students. It's not a real formal selection process. Usually people who are already teaching for Emerging Scholars just recommend other graduate students who they think would be really good at it. And the way that we have it at UIC, which may be different than other universities, is that any student can enroll in it. So it's not, Uri Treisman envisioned it to help out minority students because they were having really low success rates in calculus. But at our school, there's really no enrollment barriers. Any student can enroll. So what I did then was a study in the context of this Emerging Scholars course. It was quasi-experimental because these students self-select to be in this Emerging Scholars course. But basically, there's two types of courses. So the first was a lecture-based Transition to Proof course or Introduction to Proof course. This had the basic content that you see in these types of courses. They were introducing different proof methods. The one real burden, or something that happened that was a little bit hard to deal with, is that there were 4 different teachers teaching 4 different sections of this proof course from which these students participating in collaborative revision were drawn. And each of the 4 different teachers, after a while, started doing 4 different topics. So they all kind of started out with basic proof techniques, and then after a while, they basically did things that they liked based on really their research area. So it was a little hard to coordinate the material, and so I found myself giving little mini lectures, usually at the beginning of class, just to make sure everyone was on the same page. And so then we had this correlated 1-credit supplemental course. It met once a week for 2 hours, and this was through the Emerging Scholars program. And so this is the course that I was teaching. And this is where we did the collaborative revision. So I had kind of an advantage in that these students, most of them, were going to this lecture-based Transition to Proof class 3 days a week. And they were getting direct instruction on these different things. And then 1 day a week, they came to this other course, and we did a lot of things that are very similar to what you do in an IBL course. So I didn't really have to do a lot of direct instruction. I didn't want to do a lot, and I didn't have to do a lot because they already had these other components. So that was one nice thing about the way that this was set up. So the course design, each week I would give them a proof, and I would say, I'd give them a statement, and I would say, come with a proof of it next week. Then they were put into small groups, about 3 or 4 students per group, and discuss the proofs one at a time. So sometimes they chose to do that on the board. Sometimes they just chose to do that on a piece of paper. I kind of left that up to them. And then a note taker was kind of responsible for documenting the feedback. So someone would kind of write down, you know, so-and-so said this about this aspect of the proof. Again, it was pretty informal, these notes that they took. And the way that I kind of collected these and the way that I assessed this was to use a proof portfolio. So it's similar to, you know, this idea of what you would do in an English class. They turned in a first draft. They turned in, you know, subsequent drafts. And then also I would collect the notes that the students took. So I could kind of see, you know, how they were incorporating each other's feedback. And then occasionally I wanted to kind of get a holistic picture of what was going on. So occasionally I would give groups the Echo Pen, which is, I think Brian Katz talked about it this morning. It's just a pen that records audio as well as what you write down. So I could see not only what they were writing down, but also it was capturing kind of the whole student's conversation. So I had some research questions, and basically, you know, I had these 2 groups. One was participating in this collaborative revision 1 day a week, and then also attending their, you know, regular lecture-based course. And the other was just attending the lecture-based course. So I had kind of, I can't call it a comparison, I can't call it a control, but a comparison group. And I wanted to look at kind of 3 main components. And these research questions are long, but the main takeaways are, the first one is I wanted to see what they think about the functions of proof. And I'll talk about that more in a second. I wanted to see, does this help in their proof validation skills? So one of the hypotheses of this study was, hey, if they're looking at each other's proofs, you know, and they're evaluating them for validity, will that help them if they do that in another setting? Will they be able to better determine if a proof is valid or invalid? And then again, does this help in their actual proof construction skills? So by the functions of proof, I've kind of drawn this a lot from the math ed literature. So, you know, we probably all agree that one of the functions of proof is verification. You know, if I come up with a statement, I want to test, is this statement true, is this statement false? But also, the researcher Gila Hanna, has talked about sometimes proof can explain not only if something is true, but why something is true. So it fulfills an explanation role. De Villiers, who is a researcher in South Africa, came up with 4 more functions of proof. Sometimes we use proof to discover new things, make generalizations. Proof is our main communication tool in mathematics. Sometimes it can just be fun, right? A lot of us like to do proof for proof's sake. And it can help in axiomatizing results. And then here's a couple more. I don't know if you guys know Weber, but he does a lot of math ed research around proof. So he came up with proof can, you know, within a proof we can identify why we have a certain definition, the way that we do. We can illustrate techniques for our students. And then finally, we can provide autonomy to our students. So they, you know, once we teach them proof, they can go out and prove things, and, you know, they can verify statements for themselves, or they can create new mathematics, you know, ultimately. So these are the functions of proof that I was looking at. Do students understand these functions of proof? If so, you know, which ones do they understand? And does collaborative revision or, you know, participating in this kind of IBL-like technique have any effect on this? So I just wanted to put this up. This is kind of the participants. And I was a little worried about using these emerging scholar students because, you know, this is extra credit that they're taking. So, you know, the kind of worry was maybe they're more motivated, maybe they're just better students to begin with. And you can kind of see here from their GPA, their mean GPA and their total GPA that wasn't really the case. You know, I calculated the GPA of just their mathematics courses, and that was a bit higher for students that were, you know, in this emerging scholars. But really, their total GPA was about the same, and none of these are, you know, those weren't significant differences at all. So, you know, even though this is not a strict control, these 2 groups were pretty similar. You can kind of see there's similar gender makeup and somewhat similar majors. And so the way that I was kind of testing some of these things, and this was a big study, but I'm just going to talk about certain components. So basically, I gave a pre-assessment and a post-assessment to both groups. It had different types of questions. One was just an open-ended question. what do you feel or what do you believe is the purpose of proof in mathematics? There were some questions on a Likert scale about, which I forgot to include, but there were some questions also on a Likert scale about, do you agree with this statement about each of those functions of proof that I put up earlier? There were 4 proofs to be evaluated as valid or invalid, and some Likert questions about, do you understand this proof? Do you think you evaluated this correctly? And then one statement where they had to construct a proof. And so this was kind of given to them at the beginning. At the end, it was exactly the same both times. Just wanted to see, where they started, where they went. Additionally, I interviewed some students, and I interviewed 2 students in the treatment group and 2 in the comparison group, and basically had them explain their reasonings about the proof validation task. So, why did you say this was valid? Why did you say this was invalid? Why did you say you didn't understand this? So on and so forth. So I'm just going to go through an overview of the results, and some of these hopefully will not be surprising and will be encouraging. Some of them will be surprising, or at least were surprising to me. So first of all, I have a bunch of studies that also measured what students in a transition to proof course believe about some of the functions of proof. And these students, the participants I had in my study actually displayed a really diverse understanding. So they did actually realize, it seems, that proof had more than just the function of verification in mathematics. And then on the pre-assessment, students in both of the groups displayed equal levels of understanding of the proof functions. They rated, the Likert questions pretty much equally, and their open response answers were pretty much equal. However, on the post-assessment, the students in the treatment group, so the students that were doing this IBL-like activity, rated several functions of proof significantly higher, and these are the ones that maybe you would even associate with IBL. So here were the ones that they rated significantly higher. Explanation, so maybe that's not surprising, right? Our students are using their proofs in class as an explanation tool. Intellectual challenge. Communication, again, they're using their proofs in class as a communication tool. And then finally, providing autonomy. So that's encouraging, right? This is exactly what we're trying to do in IBL activities is provide them with autonomy, help them transition into provers. So this was, I liked this data. This was, encouraging for me. Additionally, this did help them with their proof construction. So I had that, 7 students, almost half of them, were able to write a valid proof of the statement on the post-assessment. Interestingly enough, 0 students, 0 in both groups, were able to write a valid proof of the statement on the pre-assessment. So really, even though some of them had actually taken proof-based courses before, no one was able to write a valid proof. So, at the end, we got to where half of them could write a valid proof in the treatment group, whereas only a quarter in the comparison group. And then there's just some sort of qualitative things about, what type of proofs that they wrote. So, 5 students in the comparison group, and there was only 12 to begin with, couldn't even write a complete proof on the post-assessment. So after going through a whole semester of a transition to proof course, they couldn't even write a complete proof of the statement that I gave them, whereas only 1 student in the treatment group. So when I say complete proof, I'm not differentiating between valid and invalid. I'm just saying, they were able to write something that was, a complete set of statements to prove this thing. And then the students in the treatment group used a much wider variety of approaches. The statement I gave them was very easy to prove using something like contradiction or the contrapositive. A lot of those students did that. Some of them used a theorem that would make it pretty easy. So a lot of the students in the treatment group used a different approach than just trying to write a direct proof, whereas very few in the comparison group did that. So they're able to be more comfortable with different proof techniques. And then more students in the treatment group just improved in their proof writing. So they went from invalid to valid or something like that. So I'm almost out of time, but I want to share some results about the proof validation, which hopefully will encourage you guys to do some further studies about this. But kind of discouragingly, the students were not able to improve in their proof validation. So the average correct evaluations for the treatment group was 60% at the beginning, 60% at the end. So really 0 improvement. And the comparison group improved a little bit, although not significantly. So really I didn't see much improvement here. Go through these quickly. One thing that was interesting, if anyone knows about the proof schemes of Harrell and Souter, students in the treatment group were actually just able to really improve in their proof scheme. So the proof scheme just kind of relates to what convinces you about a proof. And the students that I interviewed in the treatment group were really able to make huge jumps in that, whereas the comparison group, not so much, even though we don't see a difference really between the two groups' validation. Okay, so here's some references, and thank you so much for attending. Also, I'll take questions.
Questions for Emily.
So I may have missed this detail, maybe you gave it that. So the students who were in the comparison group, did you track what kind of time they spent outside of class? So because the emerging scholars were getting extra time in emerging scholars, were the comparison people doing anything extra outside of class?
I didn't track that beyond like the courses that they were concurrently taking, so I didn't ask them about their study habits or anything like that. Yeah, so I don't really have that information. I do have information between the two groups about courses they had taken previously that were proof-based and courses they were taking concurrently that were proof-based. And really it seemed that, again, they were pretty similar in what I call the mathematical maturity, right? Like students had taken pretty much about the same number of prior proof-based courses or were taking them concurrently. But that's all the information I have.
So did you see any interest at all between the two different groups, like how the students were interested on this, making this expectation of having to do proofs? Were there any interest from the student part?
Do you mean like attitudinal information?
Or just an energy that they want to do this, but they don't know how, or they actually were not interested at all, and that's what there was no improvement, or?
Well, so I mean, I would argue that there was some improvement, especially in their proof construction and stuff like that. I mean, I don't know. I don't have information beyond the interviews about what their thoughts were on proof validation. But I do have some attitudinal data from the students, both from course evaluations and from a separate survey that I sent them. And overall, they seem to like this idea and doing this. A lot of them had never seen that. There's barely any IBL type stuff that happens at our course. I can only think of one instructor in our department, which is huge, who attempts that. So, a lot of them had never done anything like this before. A lot of them had never even done emerging scholars before. And so, I think a lot of them did say that they liked it in some sense. I don't know if that was your question.
Did you notice any change in the kind of feedback that students were giving to each other through the course of the semester?
Yes, definitely. And that's a great question, and that's kind of what I forgot to mention is that, at the beginning, it was kind of like pulling teeth. I had to, my role in this was just going around between the groups constantly. And at the beginning, the students would present a proof, and everyone would be like, yeah, that looks good. And I'd have to be like, oh, okay, can you explain this part? And then when I asked someone else to explain, they'd be like, oh, well, yeah, maybe I don't get that part, And so definitely at the beginning, I had to really get in there and really be like, hey, do you really understand this? Whereas towards the end, they got there. And, talking to other people at this conference, that seems like the norm, kind of. Students aren't used to this. And so, but yes, I did definitely have that. And towards the end, they were really, giving each other much better feedback.
Got 1 more minute for another question? Okay.
So you mentioned that only 47% of the ESP students versus 25% of the comparison group, as you call them, were able to write an acceptable proof. Mm-hmm. Did you just have a general rubric that you used, or how did you make that determination?
Yeah, that's a good question. And I ended up making like a different category. I made like a valid category and what I called weak valid, because a lot of them, basically a lot of them wrote a proof that could be turned into a valid proof. They just, left out some details here or there. So I did have to do that. But mostly it was, one of these 4 categories. Valid, like, yes, that's fine. Weak valid, yes, they get the idea. Invalid, no, there's, some major flaw in there, or incomplete, where they just stopped somewhere in the middle of the proof.
All right, let's thank Emily one more time.